In this fourth segment of the video, we're going to continue on working creating mathematical models from data you've taken. I want you to recall that when you finish this lesson, you should be able to recall the meaning of the various parts or symbols of a linear equation. You should be able to make a mathematical equation from a graph that you've made, use that mathematical model to calculate or predict a value or number, and be able to interpret the meaning of the slope of your mathematical model. What we're going to do now is take a look at situations of data where it's not linear. In fact, that's most of the data that we've taken. Most of our graphs have been increasing shrinking rate graphs. There could be an increasing growing rate or a decreasing shrinking rate, etc. You know, there's 7 of those different relationships. So how do we get an equation if our graph is not linear? Well, I suppose some of you have had some math classes where you've looked at equations of nonlinear graphs, but I'm going to assume that's not the case. Instead, we're going to take an approach called linearization. We're going to make a line out of data. Here's a sample set of data. This is some data directly from like an inertia oscillator. And so, you know, we have a fit like this, which is an increasing shrinking rate fit. Now in math class, that's known as a square root function. It generally has the form like that. This is mass in seconds, and this is period in seconds. Excuse me, this should be in grams. And so the process of linearization goes like this. We're going to make a new chart. Instead of plain mass here, we're going to make a graph of square root of mass and period. And so I'm going to get my calculator out and I'm going to take the square root of 230. I'm going to get 15 rounded. Take the square root of 335 and I'm going to get 18. You can take your calculator out, pause the video and try this. I'm going to take 440, take the square root of that, get 21, and I get 23 for 545, 25 for 650, and 27 for 775. I'm going to bring the periods down directly. Now the reason I took the square roots is because this kind of shape is a square root function. And so it turns out if I do that, bring these numbers down here, it turns out if I take the square root of the mass, then in fact what I'm going to get is a set of data that will plot linearly. So here's the data that I've got, and I'm going to grab this data, haul it over to the next page, and we'll take a look at that, haul it over to the next page, and take a look at a graph of that. So here's that data right here. And if we plot a graph of this, it looks like this. So this is really the square root of mass, and this is the period. And you can see from this graph that it's very linear. And so now we can go ahead and make a mathematical model. Again, what we're going to do is pick 2 points on our line to find the slope. I want you to recall that the mathematical model will be made from the basic form y equals mx plus b. All right, so let's pick 2 points on our line, right there and there, and we're going to go ahead and find the slope. Slope will be y2 minus y1 over x2 minus x1, rise over run. All right, so this is going to be about 0.6 minus 0 divided by about 13 minus 0. And we'll go ahead and use our calculator to figure that out. All right, so that's 0.046. And in the next segment, we'll go ahead and work with that.